Welcome to our investigation on the magnitude of charge using balloons. This experiment was conducted and recorded by Michael Moran, Eleni Bills, and John Robertson. The problem at hand was that balloons can become charged after rubbing on objects, but there's no direct way to measure the charge on each individual balloon. Our goal was to utilize two equal balloons and levitate one over the other to calculate the individual force of each balloon. We hypothesized that if a balloon is levitated over another one of consistent mass and applied charge, then the opposing forces of gravity and electricity, Coulomb's constant, and levitation height can be used to solve for individual charge. It was found that each balloon had a charge of plus or minus 3.02 times 10 to the negative 7th coulombs.
I know what you might be thinking. What in the world is electric force? Electric force is the force exerted by a charged object onto another object. The magnitude of this force is determined by the charges of such objects and the distance between them, with a constant. The charges are measured in coulombs, force in newtons, and distance in meters.
Here's our experimental design. First, we blew up the two balloons with 3 full breaths. Then we discharged the balloons by placing them on a metal outlet for 5 seconds. After the balloons were discharged, we rubbed both balloons back and forth on John's sweater for 5 seconds. This gave each balloon an equal charge. Next, we held the bottom balloon in a fixed position and held the top balloon directly above it. Once this was done, we released the top balloon with the meter stick directly behind it and pressed record. We used tracker to track the distance between the two charges.
In order to carry out this experiment, we first need to make some assumptions and definitions. We define the bottom balloon as the fixed and the top as the levitating balloon. We assume that there's zero acceleration on the levitating balloon, that the mass and surface area of each balloon was the same, that each balloon will start with the same charge, that the balloons will have the same amount of charge, and that there will be no charge transfer between the balloons and their surroundings.
This is a model/free body diagram of the balloons at the point of zero acceleration. As you can see, the electric force and gravitational force are equal in magnitude but opposite in direction. This is a system schema for the experiment. The two objects in the system are the balloons and the electric interaction between the balloons. Outside the system is the Earth and the gravitational interactions between it and the balloons.
From Mike's explanation of the models, we can see that they represent our experiment accurately because they display all the required forces and interactions necessary to calculate the charge.
Our data analysis was done in the Tracker software. On the left, we can see a chart provided by Tracker that shows time, the y position, and the calculated acceleration in the y direction. From that graph, we can use the tape measure tool in Tracker to use the specific time that the acceleration was 0 to then find the distance between the levitating and the fixed balloon, which was 0.15 meters or about 16 centimeters.
The two equations we used for the calculations are the equation for the force of gravity, shown here with its components and associated units, as well as the equation for electric force, shown here with its components and associated units.
Here are our calculations. We first calculated the force of gravity on our levitating balloon by multiplying the mass times gravity. With this calculation, we were able to set the particular value equal to our electrical force. Lastly, we determined the distance between the two charges using Tracker. Once this was done, we plugged the electrical force and distance between the two balloons into the electrical force equation. This allowed us to solve for our charge letter Q, plus or minus 3.02 times 10 to the negative 7 coulombs.
The charge remains plus or minus because we are taking a square root and know only that the charges are like and not the sign of the charges. If each balloon started at neutral after grounding, and we know the charge of the balloon, we can calculate the electron transfer. Since we know that each electron has a charge of 1.6 times 10 to the negative 19th coulombs, using Stoic, we figured out that 1.8 times 10 to the 12th electrons were transferred.
Now let's connect what we have shown to current physics concepts. Net forces equal 0. At a stationary state, the floating balloon has no acceleration in the positive or negative direction. No net acceleration displays that the two forces acting on the floating balloon are in equilibrium and they are equal and opposite. Next are the interaction of charges. Like charges repel, opposite charges attract one another. Since the balloons repelled, their charges were of the same sign.
There were many limitations in this experiment, one being that it was hard to keep the balloons steady since they moved slightly in the x direction. Moreover, the balloons may not have been discharged across the entire surface as we grounded them. Lastly, the balloons may have had an uneven distribution of charge due to a possible charge transfer from our bodies and the way the balloons were rubbed.
In conclusion, this experiment allowed us to calculate a charge of plus or minus 3.02 times 10 to the negative coulombs on each of the balloons using physics concepts we already know of Coulomb's law and electrical and gravitational force. Therefore, it's important to acknowledge that different forces acting on our objects in order to solve problems at hand.